Hello and welcome to the channel, Statistics Decoded. This channel is for everyone who is keen to master the art of statistics but find it difficult to understand. We teach statistics in a simple way with sufficient real-life examples. Let us start with the first topic, types of data. To begin with, let us start with the definition of statistics. What is statistics? Statistics is defined as the collection, analysis, interpretation and presentation of data. Thus, you can see that data is the raw material for statistical analysis. What is data? Data are measurements or observations that are collected as a source of information. They may consist of facts, numbers, names, figures or description of things. Sources of data. Data can be sourced by personally collecting it through interviews, surveys or experiments, which is called primary data. Data can also be sourced from government database, example, census data, books, newspapers, journals or internet sources, which is called secondary data. In order to extract meaningful information from the data through statistical analysis, you must have a thorough understanding of the different types of data. Let us have a look at the different types of data. In the diagram, you can see that data can be classified into two major classes, categorical data and numerical data. Categorical data, which is also called qualitative data, is of two types, nominal data and ordinal data. Similarly, numerical data, also called quantitative data, is of two types, discrete data and continuous data. You have seen that there are two classes of data, categorical data, also called qualitative data, numerical data, also called quantitative data. So, what is categorical data? Categorical data is data that can be grouped into categories. Examples: gender can be grouped as male and female, blood group can be categorized into a positive, a negative, O positive and O negative, student grades can be grouped into grade A, grade B, and grade C, customers can be categorized into good, average and poor based on their satisfaction level of a product. Now let us see what numerical data is. Numerical data is data that can be measured. Examples are height, weight, income, marks, IQ score. The figure shows further classification of categorical data. Categorical data can be further classified into two, nominal data and ordinal data. Examples of nominal data are gender, blood group and eye color. Examples of ordinal data are income level and customer satisfaction level. Nominal data. Nominal data is used to categorize variables without any type of quantitative value. It has no hierarchy. For example, you can code it as male 1 and female 2. It could be female 1 and male 2 as there is no hierarchy. Likewise, blood group such as a positive, a negative, O positive, O negative also has no hierarchy, order. Eye color, marital status, religion, country are also examples of nominal data. So, nominal data is data which can be categorized but it has no hierarchy, order. Nominal data is best represented in pie or bar charts. Ordinal data. Ordinal data shows where a number is in order, remember, order, to identify ordinal data. Good 3. Average 2. Poor 1. Income level, low, medium, high, student grade, A grade, B grade, C grade, educational level, elementary, high school, graduate, are other examples of ordinal data. However, you cannot do arithmetic calculations with ordinal numbers because they only show sequence. It is hierarchical but the interval between them is not clear and hence they have no mathematical value. They can be visualized in bar charts. Here are some tips to identify nominal and ordinal data. Ask yourself if the data can be categorized. If the data can be divided into mutually exclusive categories, then it is nominal data. For example, the data, gender, can be categorized into mutually exclusive categories, male and female. Ask yourself if the data can be ranked. If the data can be ranked from least to greatest as first, second, third or best to worst as good, average, poor, then it is ordinal data. However, the intervals between the categories are not equal. For example, customers may be asked to rate their satisfaction on a scale from 1 to 5, with 5 being very satisfied, 4 satisfied, 3 neither satisfied nor dissatisfied, 2 dissatisfied and 1 being very dissatisfied. However, We cannot say that the difference between a 4 and 5 is the same as the difference between a 3 and 4. Some more tips to identify nominal and ordinal data. Look at the labels for the data. If the labels are nouns, then the data is nominal. If the labels are adjectives, then the data is ordinal. For example, the labels for the data, gender, are nouns, male and female. The labels for the data, customer satisfaction ratings, are adjectives, very dissatisfied, dissatisfied, neutral, satisfied, and very satisfied. Like categorical data, numerical data can be classified into two types: discrete data and continuous data. Number of students in a class, number of employees in a company are examples of discrete data. Examples of continuous data are height of adults and salary of employees in a company. More about discrete data. Discrete data are countable but not measurable. It cannot be divided. The number of votes a candidate received in an election, the number of employees in a company, the number of respondents in a survey are all examples of discrete data. Some applications of discrete data are: the number of sold tickets of an event will allow us to find out the number of attendees and make arrangements for them. The number of students in a class may help us in concluding whether the class is overcrowded or not. Likewise, the number of employees in an organization will enable us to determine the size of the company. Discrete data can be visualized in bar graphs. The chart shows that there are 40 students each in classes 12 and 11, 35 students in class 10, 45 students in class 9 and 35 students in class 8. You can see from the chart that class 9 is overcrowded compared to the other classes. The next type of numerical data is continuous data. Continuous data is a type of numerical data that represents precise measurements of nearly any numeric value. Example: a person's height could be any value within the range of human heights, not just certain fixed heights. It is uncountable but measurable. Since its measurement is accurate, it can be given as fractions or decimals. For example, height can be measured in meters, centimeters or millimeters. Time, temperature, wind speed, income, weight, pulse, height, length, unemployment rate and speed of a car are all examples of continuous data. Here are some ways to identify discrete and continuous data. Can you count it? If you can count the number of possible values of a data, then it is discrete data. For example, you can count the number of students in a class or the number of cars in a parking lot. Can you measure it? If you can measure the value of a variable to any degree of precision, then it is continuous data. For example, you can measure the height of a person, the weight of a car, or the temperature of a room. Does it make sense to talk about the average? If it makes sense to talk about the average of a variable, then it is continuous data. For example, it makes sense to talk about the average height of people in a class, or the average weight of cars in a parking lot. However, it does not make sense to talk about the average number of students in a class. Continuous data are of two types: interval data and ratio data. The major difference between interval data and ratio data is that interval data does not have a true zero. Example, height of a person, it cannot be negative, but ratio data have a true zero. Example, temperature, there is -10 C. Continuous data can be visualized in histogram. The chart reveals that 2 students have obtained marks between 0 to 10, 8 students have obtained marks between 11 to 20, 6 students between 21 to 30, 16 students between 31 to 40 and 8 students between 41 to 50. The highest number of students, 16 students, has obtained marks between 31 and 40. Here is an example dataset containing nominal, ordinal, discrete and continuous data. You can see that the number of students is given in the first column, which is discrete data because it is only count. The second column shows the gender of students, which is nominal data because it is categorical data but without any order. The third column shows the socioeconomic status of students, which is ordinal data because it is categorical data but with some order: high, average, low. The last column shows the marks of students, which is continuous data, which are measurable numerical values. One more example of dataset containing nominal, ordinal, discrete and continuous data is provided here. You can see that the number of employees in an organization is given in the first column, which is discrete data because it is only count. The second column shows the gender of employees, which is nominal data because it is categorical data but without any order. The third column shows the hierarchy of employees in the organization, which is ordinal data because it is categorical data but with some order, top, middle, lower. The last column shows the annual salary of employees, which is continuous data, which are measurable numerical values. To sum up, two classes of data, categorical and numerical. Categorical data are of two types, nominal and ordinal. Nominal data are categorical data without any order. Example, gender, male, female, eye color, brown, black, blue, marital status, married, unmarried. Ordinal data are categorical data with some order. Example, income level, high, average, low, grade, A grade, B grade and C grade. Numerical data is of two types, discrete and continuous. Discrete data are countable but not measurable. Example, number of students in a class. Continuous data are measurable but not countable. Example, height, exam marks and IQ score. If you find this module interesting, please comment, share and subscribe for more videos like this. Now reinforce what you have learned in this module with some questions. The right answer is also provided. Thank you. In the next video, the first part of the descriptive statistics, measures of central tendency, such as arithmetic mean, median and mode is explained in a very simplified manner. Watch. Hope this presentation video was easy to follow. Give your comments. Subscribe for more videos. Thank you. Next topic, measures of central tendency.